cells in it. Cells. Find something with cells. Cells. Oh my goodness. Pick up something green with cells. Pick up something pink with cells. Oh my goodness. Well, solar panels came from looking at plant cells. Plants are able to make their own food. They photosynthesize. And we're going to be looking at plants underneath microscopes using hydrants and things of that sort. So the big focus for today is looking at nature, but how as humans we have borrowed ideas from nature. So what does biomimicry mean? Bio means what? Like, and mimic, when we mimic, we are copying. So when we look at biomimicry, we're looking at copying things from life. Look in the items in your bag, each one of you pick up something and see if you can find a pattern. Are you ready? I'm going to ask for some volunteers. I would like for you to share with us a pattern that you observe. As a group, think about the patterns in the starfish. Radial symmetry.
The leaf.
The leaf. Wow. Pick up your leaf right now. Pick up your leaf. Do you see any patterns in that leaf? What do those patterns remind you of? Look at there's a top side of the leaf and there's a back side of the leaf. Take your hand and rub it down the back side of the leaf. Do you feel, is it smooth or is it rough? It's rough, it's dimensional. Okay, so look at those veins, and now I want you to look at your hands. Look at the palm of your hands. Do you see any similarity? Can you see those little sections? Can you see the patterns in nature? Isn't that exciting? It is. It is. Thank you.
On one side and down on the other one.
Oh, excellent. It has a spiral design. The shell. So look at your pine cone and look at the spiral patterns. Look at the pattern in that. Your daughter collect items from nature, and I give you all kinds of great ideas to do with your daughter when you leave here, and one of them is exploring Fibonacci patterns in nature. Walking along, and stickers get stuck to the socks. Oh my goodness. Velcro. Oh my goodness, I love it. Velcro. Oh, can you stand up in your chair and just do that for us? Go ahead, I give you permission. I want you to see how you work that Velcro. Oh my goodness. So that Velcro, those hooks, it was flat, but one side had the hook. And the scientists worked for many years to actually come up with Velcro. But from there, you know, NASA used and everything else. They do say that's our top invention ever. Where did the idea come from? Nature. Super. Okay, so seeds travel by animals, fires, air, water. And look, very carefully pull up the seed. There you go. See, drop your pine cone seed. Is that awesome? By looking at seeds and how they travel. Okay, are you ready? Da Vinci looked at seeds when he looked at the helicopter. Not only did Da Vinci draw the first helicopter, but he also drew a parachute. Now the parachute that he designed was nothing like our modern. It was like a triangular box. But all these things here come from birds and sea travel. Now I want you to look at your airplane wing before we build our helicopter. If you have an airplane in your bag, look at the airplane. Now if you don't have an airplane in your bag, now I want you to look at the feathers. You should have several kinds of feathers in your bag. This is very, very important. Feathers. Difference in the bird feathers. One of them is fluffy. So what would that fluffy feather be used for? Warmth. The airplane. When you look at the airplane has a leading edge. The design of this is based on what? Bird wings. Okay, look at your bird feather. The flight feather. The flight feather, which is the very stiff, long one, and all of you have a flight feather. If you look at it, look at the top and the bottom, but you should be able to see the front of the feather. It actually has an airfoil, just like an airplane wing. In other words, the leading edge, where it has like a little bit of a loop. It goes a helicopter. We're going to look at those feathers up close. You're going to take that feather, look at it with your eye loop, your magnifying lens, and also the microscope. How are they similar? Think about the colors. Think about the patterns. Pretty certain those stories are not true. There are drawings, and it might have been partially built, but it's called the ornithopter. Any birders out here? What is the study of birds? Ornithology. Ornithology. There you go, ornithopter. So there's Da Vinci's idea of his airplane. His helicopter though, basically looks like a spiral type screw, and the person is actually pedaling. But our modern day helicopter is based off of that. What is going to pull it down? What force pulls it down? Gravity. Gravity was discovered by who? Big
Newton.
Isaac Newton, Sir Isaac Newton. We have to get some form of resistance. We have to make resistance in order for this to actually stay afloat. Fold over one. So we've got one fold. Then we're going to do another fold. So we're overlapping. So if I unfolded that, how many sections would I have? 3. So at the bottom, we're going to flip up the tail.
Inside.
Just a little bit. Oh my goodness, the question is very good. We're on task. Just a little air resistance. Because now when I drop it, air will get trapped under here and we'll have air resistance. So what you're going to do is stand up. You're going to get up on your 2 legs, stand up. And say, now, do you think this is going to fall differently than before? Yes. Because now we have air resistance, right? And think about pine cone seeds, maple seeds, dandelions. Your arms getting tired yet? Okay, good. Okay, reach up high and then release. Would be to have your daughter take this model and she must modify it. She must make one change only to see if that one change, if she makes more than one change, then we can't, say that particular variable will have multiple variables, okay? So right now I want you to make one modification to your helicopter. And there are scissors around, just some kind of modification. In other words, you've done something different. And we will see how it works this time. This is a great investigation of your daughter. You give her the initial model, say you have to build 10 different working odd models from that one design. That's modification.
What I did with my helicopter, when I first dropped it, I noticed that the helicopter, as it was landing, it turned kind of upside down. I was not real pleased with that because if I was riding in it, I would be upside down. So what I did was I took the bottom and I folded over the corner on the stabilizer, and I folded one way and one the other way to keep the spherical movement. Although I'm not sure if I followed the different weight of these top wings and did the opposite, it would have done better. But it did do better in staying more upright as it landed.
Okay. Anyone?
I made a fold at the bottom, an extra fold, made it a little bit heavier, and it stayed straight going down.